All right, welcome to this video. Today I'm going to be talking about 3D printed infill. So the purpose of infill is to provide structure to the center of your part, provide a printable surface to put your top layers on, and to lighten the part by using less material and reduce the print time. So I've arranged these patterns in a way that kind of makes sense. Here up at the top, we have some honeycomb patterns. In the middle here, we have cubic and gyroid. And then along the bottom, we have ones that are very comparable to one another, which is grid, rectilinear, line, and triangles. All right, so let's get into the data. So if we look at 20% infill and of all of these samples, we look at the relative time and the relative material weight graph, we notice that there's some outliers right away. The 3D honeycomb, relative to line and grid, takes way more time to print and uses a significant amount more material at 20%. All right, and this can be, extrapolated to, 15%, 30%, 40%, 60% infill. This would hold true, this trend. So we also notice that, honeycomb uses a little bit more material, but also takes a lot longer to print. All right, and so I wanted to discuss, maybe why you might choose some of these, or why you might not choose some of these. Then we have another region here that are all very similar. Maybe 2 to 6% more print time, but roughly using the same amount of material. And that is triangle, shown with the triangles. We have cubic and gyroid shown together, almost on the exact same spot. And then we have rectilinear, which is very close to line and grid, and line and grid, which is, basically at the same point, all right? And so we also have another region here where we have adaptive cubic and supportive cubic. All right, so, why would you, choose, any of these over one another? Well, you might, you may exclude these honeycomb variety infills because they take too long to print or they use too much material. That's a valid reason, to not use those. But let's take a look at another chart here. Here we have the infill right here, and we have, a relative scale of perpendicular strength to weight, transverse strength to weight, the weight of the material used, and the print time. All right, and each one of these is given a star based on high performance or low performance. Star from 1 to 5. All right. Perpendicular strength is when you pull or compress on the part shown by the purple arrows, and transverse strength is when you pull it from side to side, shown with the green arrows. All right, so that's what I'm talking about when we talk about perpendicular strength to weight or transverse strength to weight. All right, so right away, I'm gonna just kind of talk about 3D honeycomb because it is maybe one of the more popular ones that you might think about using, but it actually doesn't perform at all, that good at all. So I would just suggest never use 3D honeycomb. All right, I haven't found a use for it yet. It has average perpendicular strength, below average transverse strength. It weighs a lot and it takes a long time to print. So I would just say don't use this one. It doesn't make sense to use, all right? You may want to use honeycomb. It has really good compressive and tensile strength. along along the perpendicular direction, and not great transverse strength. So you might use this one in applications where you see all of the loads of the part in the perpendicular direction. The downside is that it's okay with weight of the print, but it takes a really long time to print. And actually, the way that it prints, the printer nozzle needs to follow all these paths, and it's actually a really shaky infill. So it kind of shakes the printer about, and the printer nozzle is constantly changing direction. So you lose a lot of efficiency in print time because of that. All right, so um, yeah. So let's see if maybe there's a better choice. If we look at line, we get almost the same perpendicular strength rating, the same transverse strength rating, and better weight utilization, and we get way better print time. So instead of using honeycomb, I would suggest using line instead. All right, and then there are others. Triangle is kind of average in both, a little bit more strength in the transverse direction, a little bit less strength in the perpendicular um, direction relative to line. So that's kind of it. They're great weight, great print time kind of properties. Um, and that's kind of the same as rectilinear. Rectilinear, I should note, let's go take a look at rectilinear. Rectilinear has the smallest distance between the structure of the infill. So that means if you have really flat top layers, they're not going to sag as much in between these points from this one here to this one here. As opposed to maybe cubic, which has a longer span. So you might get a little bit more sagging if you have a really flat top surface. So that's a reason maybe you'd want to choose rectilinear over cubic or gyroid or any other infill. All right. And actually, rectilinear is the only infill that you can print 100% infill with. If you select 100% infill in the software, it automatically goes to rectilinear. All right, let's take a look at cubic and gyroid. Cubic and gyroid are interesting because they give average strength. Here's cubic right here. You get average strength in the perpendicular direction and the transverse direction. So it's the best performer in transverse strength. All right. And same with gyroid here. And it's got really good weight and print time properties. Okay. And so this would be good for parts that need more of a homogeneous strength applications where you need both transverse and perpendicular strength. So I would, select cubic or gyroid for those applications. All right. So those are great selections for that. All right. So I'm going to now take a look at these one by one just to do an overview. Right. So I would never use 3D honeycomb. It's just not worth it. It takes a long time to print, uses a lot of material. Honeycomb is great strength in the perpendicular direction, but takes more material and longer to print. If I needed the same application, I would switch to line. All right. So that is what I would use if I needed high strength in the perpendicular direction and low material utilization and low print time. So I would select line. And if I had really flat surfaces, and I was worried about sagging between these parts or between these structures, I would choose rectilinear. All right. If I'm making full thickness parts, I would choose rectilinear as well, or 100% infill. And if I wanted homogeneous strength part, I would choose cubic or gyroid. I don't know. I don't have the information to choose one over the other at this point. There's one more thing I kind of wanted to touch on, and that is the recommended print settings. So for standard prints, I would select, between 15 to 50%. I might actually start at 15 or 20% just for a standard print. If I need the part to have some strength applications, I'm going to bump up that infill percentage, between 50 to 100%. And then, if I'm doing, figurine model prints, they're just for appearance, I would choose 0 to 15%. And then there's flexible prints that's using flexible material. That could be between 1 to 100%, depending on what you need to use. All right, so that's my overview of 3D printed infill. And now you can make design choices based on this information.